Welcome to a lesson with Dr. Powell. Let's take a look at how we can write down equivalent fractions and do that by cancellation. This is an important thing when we are looking at algebra, to be able to think of things in terms of canceling. I mean, we might think about reducing a fraction like this. How do we think about it? Well, we can divide top and bottom by the same thing, and we end up getting 3/7. Now, what we're doing is we're maintaining ratios. How do you maintain a ratio? By dividing top and bottom by the same thing or multiplying top and bottom by the same thing. And in this case, we divided. Now, what we could have thought of 9 as being 3 times 3, 21 as being 3 times 7. Now, dividing takes on a nice form in this case when we picture what's common, the 3 and the 3, and so we can divide by 3 on the top and bottom. When we divide by 3 on the top, it's like we're saying 3 divided by 3 is 1. It's like we're canceling it out. And we divide it by it on the bottom too, cancels out. So we get a cancellation. But when it cancels, it's replaced with 1 because 3 divided by 3 is 1. Okay, so we get 3/7. It's kind of a nice way of being able to simplify things. So if we had something that was in factored form, like 2 times 5 squared times 3, all over 3 times 2 to the 4th, then we think, okay, there's 1 2 up here and 4 2's down there. In terms of factors, we can take out what's common. 1 2 up there and 1 2 down here. There's a common 3 there and there, so we can cancel those. And then what are we left with? 25/8. Okay, so we could use the same idea when we just multiply something like this, 3/4 times 8. And remember how we were moving the parts of fractions around? This 8 can be thought of as being in the numerator if we want to. And then you just reduce right here, divide top and bottom by 4, or just think of sharing a common factor. So 3 times 4 times 2 over 4, and then you cancel, and you're left with 6. Or you could do 5/7, and it's very similar. Same basic idea. So you could think of this as being 5 times 2 times 7, because 14 is 2 times 7. All over 7 cancel. You're left with 10. This idea is really nice when we're looking at fractions of fractions. For instance, what if we had something like 3/4 divided by 7/6? We can multiply top and bottom by something so that these denominators go away through some kind of cancellation process. So you think whatever you multiply by has to have a 4 in it, but you also want it to have a 6 in it. I mean, if you really want to, you could do like 4 times 6 and 4 times 6, and the 6 would be gone, the 4s would be gone. Notice I'm doing the same thing, the top and bottom. Now this would work, and you get a nice cancellation, but it's not the best one you could do. So let's think about the best one that we could do here. What could we multiply more simply? That would work. In fact, maybe we'll just do it real quick just to see. So 6's cancel, 4's cancel. You're left with 18 over 28, which is actually not in simplified form. But you could continue to reduce this down, 2 times 9 and 4 times 7, which is like 2 times 2 times 7. And notice the 2's cancel. You're going to be left with 9 over 14. And that would work. But let's also think about maybe a simpler number that we could have multiplied the top and bottom here. We think about a number that has 4 as a factor and 6 as a factor, but it's the smallest one that we can get. It's called the least common multiple. And we can abbreviate, or we can write this as like LCM of 4 and 6. What is the LCM, least common multiple of 4 and 6? Well, what we can do is we can first write out 4 like in its factored form, say 2 times 2. And then we think, what do we have to add on to this at minimum so that 6 will be a factor? Well, just simply 3. Notice 6 is a factor, 4 is a factor. Well, this is the least common multiple. It would be 4 times 3, which would be 12. So we could multiply by 12. In fact, we could keep it factored as we do so. So maybe we could have approached this as follows: 3/4, 7/6, and we could have multiplied top and bottom by 12. And we could just write down 12. That's fine, because this reduces nicely because 4 divides evenly into 12. So we could just replace this with a 3, because you think 12 is 3 times 4, so cancellation. Okay, 12 is 2 times 6. You can think of that as being a 2, and that going away, it's going to be replaced with a 1. Remember that. You can even write it down if you want. So that would be 3 times 3 on the top, 7 times 2 on the bottom, which is 9/14. But notice at least it's a matter of style. You could do 3/4 times, you could do 2 times 2 times 3 if you want to just keep it factored like that, all over 7/6 times 2 times 2 times 3. Or you can even group that as 2 squared if you want. But in this form, it's nice because you see 6, 6, 4, 4, then you have 3 times 3 over 7 times 2. So that's just a matter of style there, as we take a look at that. All right, so why don't we have you try one? We're going to look at a fraction of fractions. So let's suppose we have 3/10, and we have over something like, let's see, 3/8 even. How can we work with this? Well, we could multiply top and bottom by, okay, let's think about least common multiple of 10 and 8. What would that be? Think of 10, just pick one of them, like 10, like 2 times 5. What do we have to add on to this? It looks like we already have 1, 2. We need 2 more 2's there. So we have 2 times 2 times 2 is 8. So that would work. Notice that that's 40. Okay, so we can multiply top and bottom by 40. And if we want, we could just keep it in factored form, maybe thinking of it as 2 cubed times 5 if we want. 2 cubed times 5. Notice that cancels. Here, we have one of those 2's canceling, and this 5 canceling with 10. So we're left with 2 squared, which is just 4. 4 times 3 is 12. 12 over 3 times 5, which is 15. Oh my goodness, there was something we didn't cancel out all the way. See these 3's? Those 3's could have canceled from top and bottom. Notice how that was away. So this really looked like 3 times 2 squared over 3 times 5. So we just could have canceled those immediately. In fact, even more simply than that, we could have factored them at the beginning, or canceled them at the beginning out. We could have just thought of this as being 3 times 1 over 10 divided by 3 times 1 over 8, and you could have canceled them. Very snazzy. And if we want to be creative, we could have noticed that 1/10 was the same as 1/2 times a fifth. And you could have noticed that 1/8 was a half times a half times a half. And notice that you have 1/2, 1/2, they're the same. You can cancel them out. It's 3, 3, same, you can cancel out. Then you'll be left with 1/5 over 1/4. A fifth over a fourth. And you know, looking at this, you could think, okay, this is a fifth times, you see, so you could think you could pull this 1/5 out front, is what I'm saying. You could pull it out front, so you really just get 1/5 times 1 over a fourth. And this guy, how many quarters are there in 1? There's 4. So that 4 just pops up to the top. So because this is just 4 times a fifth, which is just 4/5. And whenever you see a 1/4 in the denominator, you could just think of that 4 as just traveling up and just being its friend just right up there, and then you would get it. That's another way of thinking about it. Thanks for watching.